In the world of construction, you've always had these two things that just don't talk to each other: your super detailed visual 3D model and your flat numbers-only spreadsheet. Well, today, we're going to look at a way to finally connect them, giving your spreadsheet 3D vision. You know, if you're a quantity surveyor, an estimator, or a BIM manager, this question probably hits pretty close to home. It's the daily grind, right? You've got these amazing, data-rich 3D models over here, and your budget and cost plans living in a totally separate spreadsheet over there. And the bridge between them? It's always been you, manually typing in numbers, which is slow, it's boring, and let's be honest, it's where mistakes happen. I mean, it's a tale of two completely different worlds. Your BIM model is alive, it's dynamic, it knows everything about every single beam, window, and door. But the spreadsheet? It's just a grid of cells. It's powerful for sure, but it's totally disconnected. Every number you punch in is just floating there, cut off from the design it's supposed to represent. And that massive gap creates what you could call the estimator's disconnect. This huge chasm between what's being designed and what it's actually going to cost. So the big question is, how do we build a real, permanent bridge over that gap? Well, one answer is a tool called CellBIM, and its whole purpose is to solve this exact problem by bringing your BIM models and 2D drawings right inside Microsoft Excel. The big idea is to just stop all the exporting and importing and copy-pasting and just keep everything together in one place you already know how to use. And what's really smart is that it's not trying to force you into some brand new ecosystem. You just do a quick install, and the next time you open Excel, boom, there's a new CellBIM tab right in the ribbon. It just slides right into the workflow that, let's face it, millions of us are already using every single day. Okay, so what does it actually look like in practice? How does it work? Well, the main workflow is really simple. Just 3 key steps that take you from that complicated 3D model to precise, live measurements inside your spreadsheet. So, step 1, you bring in your design files, and it handles pretty much everything: IFC, DWG, Revit files, even PDFs. You just import it, and the model shows up in its own viewer, sitting right there next to your worksheet. Now, here's where the magic happens. This is the key. From that 3D viewer, you can grab any element, a wall, a floor slab, a door, and just drag it and drop it right into an Excel cell. And that one little action creates a live, intelligent link. That cell isn't just a cell anymore, it's a direct connection to the model. And the second that link is made, you can instantly pull the quantities: lengths, areas, volumes, how many of them there are. It all gets extracted straight from the model and fills out your spreadsheet. That cell doesn't just hold a number somebody typed in, it holds real, live data from the source. Of course, just getting a bunch of raw data is only half the job, right? You need it to be organized, you need structure. And that's exactly where templates come into play, helping you set up your takeoffs based on industry standards right from the start. So to make sure all that data is not just accurate, but also makes sense, you can use these templates. So if you're doing a cost plan in the UK, you can structure it according to NRM2. If you're capturing data for facilities management, you can use COBie. It just makes sure everyone is on the same page using the same rulebook. All right, so that's the core workflow. But what happens when you're dealing with a really, really complex model? Well, for that, there's a whole suite of advanced tools that give you some serious expert-level control. For example, instead of clicking on every single window in a skyscraper one by one, you can use auto-select to find every single similar object in the whole model in a split second. Or you can use a select box to just grab an entire floor's worth of stuff in one go. We're talking about huge time savers here. And to really dig in and check the model, you can do some cool things. You can overlay the 2D floor plans right on top of the 3D model to spot any problems. You can create section cuts to literally slice the building in half and see what's going on inside. You can even walk around it in a VR mode, almost like a video game, to get a really close look. So when you put all of this together, the direct integration, the live linking, the advanced tools, what's the big payoff? What does it all add up to? Well, it points to a pretty fundamental change in how an estimator can work. The biggest advantage, really, is that you're moving from manual work to automated data extraction. You're replacing all that tedious typing with live links, which just crushes the potential for human error. It's not only faster and way more accurate, but it also means everyone on the project is working from the same, consistent, standardized set of data. Ultimately, the goal is to go from a bunch of disconnected models and spreadsheets to a single source of truth.
Instead of chasing different file versions and wondering if your numbers are up to date, you have one place where the design and the cost are always dynamically connected.
And this brings up a much bigger question, doesn't it? As that line between the design model and the financial spreadsheet starts to fade away, what does the estimator of the future even do? Does their main skill shift from measuring things by hand to analyzing and verifying data? It might just change the whole job.